Before we get to our A+ question today, I want to go over a few geometry terms. First, let's say we have a circle. If I were to make from the center of the circle, let's call the center O, if I make an angle out here, then this is called a central angle. And that's because the vertex of the angle is at the center of the circle. We also say, let's say it comes to the point, it meets the point on the circle A and another point B, we can say that the arc AB is subtended by central angle O. So we would basically say that the angle AOB, right, referring to this angle right here, subtends arc AB, which we would write like that. Let's also say that we have another circle, and this time, instead of making an angle from the center of the circle, we make an angle and we place the vertex on the circle. We can still say that it subtends the arc AB. Let's call this point out here C. In this particular case, angle ACB subtends arc AB. But this, however, is not called a central angle because the vertex is not at the center of the circle. This is called an inscribed angle. And that's because the vertex is on the circle itself. Now there's something that is called the Inscribed Angle Theorem. And this basically says that any angle, any inscribed angle, you could measure it and it would be half the amount of the central angle that subtends the same arc. So if this were, maybe these are literally the exact same circles and A and B are at the exact same point, I would then be able to say, using the Inscribed Angle Theorem, that the inscribed angle, which is angle ACB, is 1/2 the measure of the central angle that subtends the same arc. In this case, angle AOB. So if I were to know that the measure of angle AOB, let's say it was 80 degrees, then I would be able to know that if there's an inscribed angle anywhere on the circle that subtends the same exact arc, that inscribed angle would be 40 degrees. If you want to find proof of the Inscribed Angle Theorem, keep checking back for future videos. All right, now that we know the Inscribed Angle Theorem, we're going to approach our A+ question of the day. Our A+ question today asks us to use the figure shown where point O is at the center of the circle. And our job is to find X. Now, this X is the measure of this arc. We also can say that the measure of an arc is equal to the central angle that subtends that arc. So in this drawing, for example, if I make that central angle that subtends the same arc, this angle is X degrees. We'll actually use that possibly in a little bit. First, let's go ahead and identify a few points on the line so that we can start talking about them. We're just going to say that the point right here where this original 120 degree arc is, we're going to call that point A. We'll call this other point right here point B. These points are connected to this point out here. We're going to call that point C. And these line segments, CA crosses the circle at point D, and CB crosses the circle at point E. We're going to go ahead and just label those points so that we can refer to them easier. Here's what we're going to do. We're going to draw in a line from point A to point E. Using the inscribed angle theorem that we just talked about, we're going to have central angle AOB, which we know to be 120. It subtends arc AB. So that will actually help us with another angle, this time an inscribed angle, this one right here. If you look at this angle here, the AEB, angle AEB is an inscribed angle. We know it also subtends arc AB, and by that inscribed angle theorem, we know that it's 1/2 times 120, or we could say that it is 60 degrees. I'm going to go ahead and label that. The next step, we're going to go ahead and find the measure of angle AEC, which we know is a supplementary angle. Angle AEC is supplementary to the angle AEB, and therefore they're going to add up to be 180. So we know that AEC plus AEB, which is 60, is going to give us 180. And so we could say that the measure of angle AEC is equal to 120 degrees. I'm going to go ahead and write that in. Now, next up, I want to think about triangle AEC. That's this extra long triangle here. That triangle, we know two of the angles. We want to find out the third angle. And we know that every triangle, the sum of the angles is 180. So we're going to know that in that triangle, 120 degrees, that's this one, plus 30 degrees, this one, plus our missing angle DAE, or we could even call it CAE, as point D is on the same line segment CA, that those are going to sum to be 180. When we calculate out that, we're going to get that this angle DAE is equal to 30 degrees, and that's because 120 plus 30 is 150, and you'll need 30 more to get to the 180. So I'm going to go ahead and label that 30 degrees. Now let's come back to that inscribed angle theorem. I can say that there is an inscribed angle that we can call angle DAE, and it subtends arc DE. So we see that here. We see that this angle DAE subtends this arc right there. And we also know it's given to us that this angle is 30 degrees. So then we can find out the central angle that subtends the arc DE. We're going to go ahead and find that and then name it. We're going to subtend the arc DE by this time going through the center. That's this one right here. That's angle DOE. And we know by the inscribed angle theorem, basically the reverse of what we've done earlier, that angle DOE is therefore going to have to be twice the inscribed angle, which was 30 degrees, and therefore is 60 degrees. Now, if the central angle is 60 degrees, we also can say that the arc subtended by it has a measure of 60 degrees. So in this case, X is 60 degrees. And there you go.